code, cloud, IT, silly jokes. ITT.
Hey everyone.
Hello and welcome to the new ITT video where we will show you the Decorator Design Patterns by adding it to on top of the claim check client for sending messages, which we showed you in one of the previous videos. So here we go.
Yeah, let's just jump straight to the topic. So we'll show you first a couple of pictures from website which is named Refactoring Guru. Highly recommended, very nice pictures, very nice explanations. However, I don't particularly like this example of the decorator with the notification. In the normal system we would do it slightly different, but let's just skip this one. We will just talk through the images that we have here, some of the images, and that's it, but highly recommended to just go to that website and check out what they have anyways. Super useful. Okay, so as you can see, we've got those matryoshkas in here. How it works is you got this doll that you put into another doll, into another doll, into another doll, and stuff like that. This is how the decorator pattern works essentially. So you basically create like a class that you can then inject through the constructor into another class that wraps around that first class. And when it wraps it around, it can also extend the behavior of that class. So you add another set of behaviors on top of what's already happening in there. And what you can do in like real world scenario is like add an encryption on top of that, or maybe for example you want to gzip something with the request or ungzip something, stuff like that. That's the usual stuff that you can add as a decorator, something that you can like sneak into the behavior. And it also helps you to make the unit tests easier because you then test only what's inside this decorator. We'll show that on the example. So another analogy that we can go into is this real world analogy that we have here, which is the layers of your clothes that you have on you. So when you're naked, it may be kind of cold. So you add another layer on top of that, like a sweater, for example. And then this sweater, it helps you to reduce the cold from outside world, right? And then you can add another layer that will, for example, also protect you from the rain, like a raincoat. So that's another layer that also adds new behavior on top of what's already in, which is you, effectively. So basically you put things inside of other things, and that adds another capabilities to the behavior. That's more or less it. Let's just jump straight into the code. So, as we already talked about that, we will be using the old project of ours that we already have shown in the previous video, which was the claim check pattern. So what it does, in short, if you want, just go back to the previous video to learn in details, but just in short, what's happening in there is you want to send a message from one service to another service, but this message is too big to go through the queue. So instead of sending that directly onto the queue, you can drop it into some storage, like for example, in our case to blob storage, and then you receive it on the other side through just the message that tells you in the queue where in that storage that data is, and you pick it up from that storage. That's a very common cloud pattern or integration pattern actually that you can use in your application when you want to exchange a bigger chunk of data and you have a size limit of the message in the queue. Usually works for videos, for photos, for bigger chunks of data as well, like a big JSON. In our case, it will be just a big ass string that we want to send between those services. And we'll write only one service in this case because we just want to implement the sender. We don't care about the receiver at this occasion because there's no sense in showing that for the decorator pattern. Okay, so our new project is claim check sender decorator project. It's a console app. It doesn't do too much, just sends the message onto the queue. What's different from the previous example that we've shown, it's not using storage queue anymore, because we wanted to add some metadata, because we want this to add some metadata to actually give you an information that this is a message that's been claim checked or it was encrypted. We want the consumer to see those properties of the message so it knows what to do with it. If it was claim checked, it knows what to do with a claim checked message. But usually we don't want to store everything on the blob storage, because why? If the message is small enough, maybe you have different sizes of messages, something like that. Maybe it's a collection that can grow and you don't know how big it will be, but just in case you want to handle a bigger message anyways.
And I think that's the biggest difference between the previous example we showed, where we always use the claim check pattern, like the claim check messages. Now we want to apply the new pattern to distinguish which messages should be claim checked and which and for which it's not needed. So we can save costs, we can save storage, and so on.
Yes, and we'll show you also, like, if you build a client-facing application that needs to use the claim check pattern for some reason, you want to enable that, disable, or you have a feature flag for some customers, you want to have a common code base and you have a feature toggle. For some customers you want to enable that, for some customers you want to disable that because they have a different let's say pricing tier of your service, so some can send bigger messages, some cannot, right? That could be also the case. Some can have an encryption, so some don't have the encryption available. Okay, so the usual example is we've got a sender, and this is a service message bus sender. It's a concrete implementation of something that's called iMessage sender. So if you can look onto the left side of the window, you'll see we've got a couple of directories. Just the program, which we've already seen. That's the one that we've already shown. And encryption doesn't matter that much. It's just some encryption that we use to encrypt the message, and we use that in a decorator, which we'll talk about in a second. And we've got a message that we send as an abstraction to our send message service, and iMessage sender. This is the interface that all our classes will be implementing, that we will use in this example. So we have service bus message sender, and as you can see, it implements this message sender interface that has only this one method, send async message, that we've defined ourselves, and that's it. And also it creates the service bus client sender that can send the message onto the queue. In this case, the queue is named messages. It will just drop the messages into this queue. And it has only a console write line that says, yeah, we are sending the message to the service bus. And then after that, it creates the message with the body of the message, of the custom message that we have, and assigns the custom properties that we have to application properties, because the naming in the SDK is different. However, on the Azure portal, as you will see, it's named custom properties anyways, so it's just kind of confusing. So we
just made it better.
Yeah, exactly. But we made this message abstract because that's all we want to know. Because if we would change in the future what's underneath this implementation, we don't want our interface to be dependent on the implementation of the service bus SDK.
Maybe one day Microsoft will realize that they've fucked up and named it differently, and we'll change it. So we don't want to fix our application.
We will need anyways, right? But
just in our model, which is just in the sender, which is like responsible for passing it to the service bus domain, but not in everywhere where we are sending some message.
Hopefully,
where we are using this sender.
So that's the thing that's gonna happen in here, and then we just send this message through the sender that we've created before. That's an asynchronous operation. That's it. Nothing fancy in here. Okay, what else we have here in the implementations directory? Okay, so we have, let's go into encrypted one first, because we added something on top of that, like, because why not? So what it does, it creates a new decryptor, which is actually not needed anymore because it's a static method, so I can just get rid of that, and now it's also working, all good. But the message sender, it gets the message sender in the constructor, as you can see. So what it does effectively, it gets an object that only implements this iMessage sender, so it can get anything that is able to send the message. And what it does, it also implements iMessage sender interface. So in theory, it could take itself as a parameter, but it can also take claim checked message sender or service bus message sender, because those also implement iMessage sender interface. And it overrides the send async, like implements in here in this example, send async method as well. And what it does, it's basically logging that is encrypting the message, setting the flag, the custom property that we've seen on the message object, that it is an encrypted message, and also tries to encrypt the message, encrypts the message actually, and sets it as the new body of the message, and also invokes the method of the message sender that it received as the parameter in the constructor. That's very important. So it adds some behavior on top and then invokes the logic that's inside of the object. Another thing which is slightly more complicated is the claim checked sender. It does the same. So it gets the iMessage sender interface and implements it at the same time, and it gets it in the parameter. And it also overrides the send async method. And as you can see, it checks if it should be claim checked based on the size of the message. And then if it is, it says that, okay, I'm claim checking the message, which means I'm uploading that to blob. This method is a helper method. It just generates the blob name, some GUID, and returns the blob name and drops the message onto the blob, obviously. And then what it does, it sets the new body of the message, which is the name of the blob. So not a message anymore, because it was too big to put it into the queue. And then we are setting a custom property, which is claim checked, set to true, and that's it. Should be the same type, I assume. And that's just it. And then it invokes the message sender, send async, so anything that's inside of the send async method that it has in the object that it received, it will be invoked. That's it. Nothing really more fancy than that. So as you can see, it's super simple then to just test the added functionality in here. So you can test this logic on its own and just check if the below was invoked, but you check only this in unit tests. Same for the encryption. You just check this logic, right? And then if this has been invoked. It's super easy to mock that, super easy to add this behavior. And not only that, but you can also control how you put those things together. You can put one in another one and stuff like that. You don't have to use the encryption sender on top of the service bus message sender. And we'll show that in a demo in a moment, that you can actually quite nicely mix all of that at the same time. So we'll show you the outcome of that. Okay, so that's basically it. In const, we just have a connection string to the service bus. It's not a good practice, but it's just for the demo purposes. And okay, so we have this encrypted sender and it already sends the message. But to be honest, let's start with the sender itself. So those two won't be used. We can just comment them out for a second. And this will send the message with a character times 127, and that's it. Oh, sorry, 127 times 1024. So it will be quite big. That's what she said. And let's just hit. Oh, sorry, maybe not build, but also debug.
Execute it.
Exactly.
So we are unpacking our matryoshka right now.
Yes, for now it will be just a single message that went into the queue. So we can get back to our browser, go to the service bus, to Azure portal. As you can see, there's one message queue named messages, very, very good naming convention. And we go to Service Bus Explorer, and as
we
you
are
can see
sending
here,
messages to the messages.
To pick up the messages. Hey Dawg, I've heard you like messages. Okay, let's just receive them. I'll put 5 in here just for the future. Oh, maybe not pick and lock, but okay.
You know, I can really relate to these signs sometimes.
So those are the messages. We can see the message properties. We've got custom properties that we mentioned before. Then there are known. Let me just complete the message. So it will be removed from the queue, but we'll change the mode next time to receive and delete. So we don't need to click on that button anymore. Okay, let's go back to Rider. And in here, we'll make a change. We'll make a change that will add maybe something that we can see. So claim check sender, and we'll send 2 messages this time. It's the same message effectively, but sent through 2 different senders. So it will send it 2 times. It's a bit confusing, but the sender itself, as you can see, is sending 1 message. Maybe we can do it in a more clean, slightly more clean way, like where we use them. Because they're like connected to each other, right? So as you can see, there's a sender that is sending the message, and then there's the claim checked sender that takes sender as the parameter, which means it also uses its method after it's doing its job. And then we invoke send async as well on this message. The same message, just sent twice. We can run the application once again. Okay, it said it sent the message to service bus twice. And let's see what happened in the Azure portal. So refresh. Okay, we've got 2 messages, receive them, receive and delete, obviously. Okay, and we have those 2 messages. As you can see, the first message is the same, and the second message will be also the same, because the claim check pattern didn't do the claim check itself, right? Why? Because it didn't classify that as a big enough message to claim check it. But if we change it to 130, so now it should invoke its logic. Let's just run it once again. Okay, so I run it for the second time, and this time we've got a sending message to service bus, claim checking message, send message to service bus. So as we can see, it's already using that, because I've changed also the size of the message to be claim checked. So this time the behavior was added because there was this if checking if it should be claim checked. And now we can check in the browser if it really have an effect. So let's just refresh once again and let's hit receive messages. Okay, so we have those 2 messages and we can go to the first one. Obviously, same stuff, no custom properties as expected, but the other one, we can see there's a custom property which says is claim checked set to true. So what do we expect in the body? In the body we got a GUID that says where that is exactly in the storage account. So we now have a file in the, or actually a blob, but let's call it a file in blob storage that has this data in it, this AAAAAA, and now we just know where it is. So the receiver can say, okay, I got a custom property that says it's claim checked. I know what to do with it. I will download it from the blob storage. That's it. Cool. Let's go back to Rider. And in here, let's use another sender that is encrypted. So this encrypted message sender is taking the claim checked sender as the parameter and then uses its own send async method. So this encrypted sender will add its behavior, the claim checked sender will use its behavior, then use the sender to invoke its logic to send it to the service bus. So if we would run this time, you'll see it sends 3 messages this time. So the first message is sending message to service bus. Cool, that's what we expected. Then we've got claim checking message. So the claim check invoked, then sending message to service bus. Then the next one, which is starting with encrypting the message, then sending message to service bus. And it didn't claim check it. Why? So if we would go back to the browser and also hit refresh again and receive messages and wait like 5 hours to get the messages from the service bus explorer. Okay, so the message body is like that, and the properties are is claim checked set to true and is encrypt set to true. But it doesn't look right, so it seems like we have a bug in our code. So let's go back to the Rider, and it seems like we've been modifying the message in the background because we use the same object and we modify this object in the send async method. So by the time it goes to the encrypted, it already has a different body because of the claim check pattern used before. Okay, so we added that into our object message that it now can clone itself, which is cool, but we need to use that somewhere, and we will use that in the implementation of this method. So it will be confi for us, var intern, or maybe msg message clone, right? Because we are in the local context, so doesn't have to be the best naming convention in the local context. It can be a quicker one, a smaller one, and we are operating now on the message. Let's just make double sure that we are in the right spot. Like that. Okay. The next one, it will be this one. It was not necessary for the sender, but just in case, if we would like to do anything with that, var this one. And now we want to operate on, instead of this message, everywhere on the MSG.
So now our method doesn't have the side effect, which is modifying the input parameter.
Exactly.
And as you can see, it's very dangerous when you are modifying something what is sent to you, because then your client can expect that it's unchanged and use it in a little different use case. Like in our case, we wanted to send encrypted message, but it was modified by the previous sender. So we also showed you the anti-pattern of like you have to avoid
modifying the state.
Modifying the state in your messages, in your methods. Yeah.
Mm-hmm. Yes. Okay, cool. So let's run it again and let's see what's the outcome of that. Okay, the first one, then claim check message, then again the next one, then encryption, claim check, and send. So it looks good. Let's go to the browser. Okay, so now we have 3 messages. We can look them up.
And now fingers crossed.
Okay, and in this case, we've got, again, the message itself. Then we have the claim checked message, so we have only a GUID in here. And the last bit is, again, just the message body, which is a GUID as well, but in the message properties, we know that this message inside is encrypted and is claim checked as well. So it all worked like we would be expecting. Cool. Some debugging on the flight, but yeah, fix on the production as always. So if we go to the center, back to the rider, you can see we've used all of them. Obviously, the point is just to use maybe one of them at some point, like just the encrypted one, and just send the one message with all those behaviors on top of each other, rather than sending everything one after another. But maybe we would like to sometimes add the senders, the claim check, sometimes add the encryption. So how we can do it is, for example, create a builder that would compose for us those different decorators, one on top of each of another, if that would be needed. So it's not like the finished product yet, but it's a direction in which we could go. We can also have like a simple method that will resolve for us a specific one. But what's super good about it is you can tell how easy it will be to test this behavior and how easy it will be to write the unit test for each part of it, rather than making like a big project. And also, the most important thing, you can configure that in runtime. So you can have a feature flag in here that will say, okay, I want this behavior, I don't want this behavior. You can ask like your user if the user wants to have different decorators stacked on top of each other. You can also, instead of, for example, adding the logging here, right, we could add decorators that would add the logging for us, instead of having this in, maybe not in this case, but in this case, for example. Or we want to measure, for example, how long it would take to send the message into the service bus. We can have we can add a behavior that would, a decorator that would basically invoke that, before invoking that send async method, would start a timer and then check after it's invoked. So in here we can also add some logic, right? We don't have to add the logic only before send async method. We can do it after it as well and modify the response, for example. Yeah, so that's pretty much it. And hopefully it's useful for somebody. And yeah, thanks for watching, and see you in the next episodes. Cheers.
Thank you. Bye.